All right, so hopefully you watched the parent function videos and were able to, at the very least, remember what those parent functions look like: quadratic, reciprocal, absolute value, and so on. Now we're going to look at transforming those parent functions in some given equations to get some unique graphs. So if you're my on level, then we're going to be in our packet, and we're going to actually in this video flip through the packet to where it says transforming parent graphs. That's actually where we'll start here in this video. If you're in pre-AP, then you don't have this packet, but still the information here is something that's going to be helpful as we do our work. Okay? So the first thing we're going to look at when we talk about transformations of parent functions. So we know what our parent functions look like. We might have a quadratic, but we can move that quadratic left and right, up and down, and so we want to talk about what those equations might look like and how those equations can, those different equations can affect the shape of that graph and how we can move it around and get a good image. Okay. So, a function typically comes in the following form. This, of course, looks extremely daunting, but it's not too bad. You'll have a given function, and we'll do a concrete example here in a second. But there is this idea that you can multiply a given function f of x by a number, or you could add or subtract a number at the end of a function and there's some result. And so we're just going to kind of remind ourselves what each of these could do. If there is a negative sign in the very, very front of your function, hopefully you remember that that's a reflection, and you, again, hopefully remember that specifically it's a reflection over the x-axis. If there's a negative on the inside of the function, in front of the variable x, then that too is a reflection, but that's a reflection over the y-axis. This is the kind of notation that I'm going to use to say reflection over the x-axis, reflection over the y-axis. If there's a value in front here being multiplied, maybe this is a 2 or a 5 or a 15, then that's a vertical stretch by a factor of a. Vertical stretch by a factor of a. You may ask, well, what if this is like 1/2 or 1/3, a number that's less than 1? Then that would be a vertical compression by a factor of a. I'm not terribly picky about VS versus VC, as long as you remember that if there's a number being multiplied in front of your function, then that's going to affect your y values by that factor. Okay, and we'll do plenty of examples where we see this. Just kind of reminding you what that value does. And then there's these last two. Let's do the easy one. What happens if you add or subtract a number at the end of your function? So maybe +5, -2. What does that do? And I hope you remember that that means it's going to take your function up or down. Up if that's a +5, +7. Down if that's a -2, -8. And then in here, again, you probably remember that if it's like x +3 or x -9, then that's going to move the graph left and right. But you also probably remember that if it was like x -2, that's actually right 2. So if it's a minus sign, that's right 2. And if it's a positive sign, like x +3, that would be left 3. Okay? So these are really all the transformations that we could see in our class. If you're in pre-AP, you might see a value in front of x, maybe some number here, so like -3x, and that would actually be a horizontal stretch or compression by a factor of 1/b. But that's just for pre-AP, and we'll talk about that if you're in pre-AP in our live sessions. Okay? But if you're on level with me, then we're just going to worry about these 5. Okay? But it's not enough to just be able to identify them. We also need to know what's the order that we do things in. Sometimes you don't get the same result if you go, down first and then reflect and then go left and versus doing some other order. So there's actually a set of steps that we want to make sure that we follow as we do this. We can't just do all of them at once and expect to get the same result. We want to make sure that we're following the right order. And the order is pretty simple. Hopefully you remember the first thing that you're going to do, very first thing, is go left or right. We want to make sure that the very first thing we do is go left or right. So if you see an x plus 3 or an x minus 5, that's the first thing we're going to do. We're going to make sure that the last thing we do is up or down. Okay? So we very much want this to be the first thing we do, and we very much want this to be the last thing we do. Okay? So then maybe the question is, what's the order in the middle here? And that actually isn't going to matter. We could do it in any order, but since we're, we know that this is first and this is last, maybe we just go in order. Maybe we reflect over the x-axis second, vertical stretch, and reflect over the y-axis. That's more than fine. The order doesn't matter in the middle here. As long as you're for sure going left first and for sure going up and down last, you'll be in good shape. Okay? Let's do a concrete example of this, just to get an idea of what I mean here. So what if I said y equals -2 times x plus 3 squared minus 1? There's a lot of transformations going on here. Hopefully you agree that the parent function is x squared. That's kind of the f here. We're using the parent function f of x equals x squared. But then there's a lot going on here. There's a 2 out front, a -1. So let's identify what each of these does and the order in which we do things. So the first thing we would do here is left or right. Is there any movement left or right? And I hope you'll agree that this x plus 3 is movement to the left 3 units. What's the second thing? Well, per our list, again, as long as we just go up and down last, but maybe the second thing is just to check, is there a reflection? In this case, there is. So there is a reflection over the x-axis. Is there a vertical stretch? And there's that 2 in front, that a value. So there is a vertical stretch by a factor of 2. I'll put vs2. If you put vs by 2 or y by 2, that's fine. Is there a reflection over the y-axis? And no, there's not a negative in front of the x, so there is no reflection over the y-axis, so we're good there. And so then the last thing would be, is there any movement up or down? And I hope you'll all agree that yes, there's down 1. So this thing will get moved left 3, reflected over the x-axis, stretched vertically by 2, and moved down 1. So this is actually going to end up being pretty straightforward to graph because we know what the parent function is, y equals x squared, and we just watch a bunch of videos reminding ourselves what that thing looked like. And so now if I can take this original parent function, identify how it's been moved, I can take this original function, move it left 3, reflect it over the x-axis, multiply its y values by 2, and shift everything down 1 to get a good graph of what this thing looks like. Okay? So that's what this says. The first thing we would do is left or right. The last thing we would do is up or down. And then it says, in between horizontal and vertical shifts, you can list reflections and any changes in the width or any dilations, vertical stretches, and so on in any order. That's what we just talked about. And then these are the examples that we're going to run through. It just wants us to list the transformations in order for the following equations. So let's, I'm going to go pretty fast here. If I look at this equation, the first thing I see is that there's movement left 4. The next thing I see is that there's that negative out front. That's a reflection over the x-axis. There's that 3 out front. That's a vertical stretch by a factor of 3. And then there's this plus 5, up 5. So that's the transformations in order. Cool. Something that I also am going to ask you to do in these problems is go ahead and tell me what the parent function is, just because we're going to need that as we start to graph these things. So what's the parent function? Kind of what's being done to x here? And it looks like x is ultimately being squared. X squared is the parent function. So this used to look like our standard quadratic, and then it's been moved according to what we've just analyzed. Okay, let's look at example 1 here. The first thing that's going on looks like that x minus 2 tells me write 2 in the middle, and then there's that 2 out front. That's a vertical stretch by a factor of 2. And then again, our parent function is at the quadratic. Cool. Notice there was no negative in front of the 2 or the x, so there is no reflection. And there's no number being added here, so there is no up or down. Okay? What about this? Look at the inside first for that left and right stuff. There is an x plus 4 that's a left 4. Okay? There is a negative out front, so that's a reflection over the x-axis. Notice there is no number out front, unless you thought, like 1, but there's no number out front that's being multiplied, so we don't worry about any vertical stretches. So the last thing that's going on here is that down 7. And what's the parent function? Kind of what's being done to x? And it looks like there's that x plus 4, but it's all inside of an absolute value. So the parent function here is the absolute value function. We remember, of course, what that looks like. And so if we remember what it used to look like, and we know how it's been moved, we can graph this. Moving this whole thing left 4, reflecting it, and down isn't all that challenging if, again, you can identify what it used to be, its parent function, and how it's been moved. Graphing these things isn't too bad. What about this? This one's kind of tough, actually. It looks like we've got that minus 3 here, so right 3. There's this negative, so reflection over the y-axis, and then there's this 1/3. It's a vertical stretch, or you could say a vertical compression, since it's less than 1, 1/3. Okay. And the parent function is the square root of x, which remember is this thing. Okay, and then the last one, it actually got cut off, so I'm not going to do that. I may do that in the live sessions. Okay. In the next video, we're going to actually put all of that work together and learn to graph these things, and then look at how we write equations for those graphs.